We are now into our last session for today. So we're now going into session 4, and we're going to talk about water provision related issues in emergencies. And so now we will turn over the presentation and the floor to Robin. Robin, are you with us?
Good afternoon, or to those of you who, like me, are sitting in the dark. It's 10 o'clock here. Good evening. I'm excited to have been able to listen to so many interesting discussions today and look forward for what's yet to come for the rest of this week. My name is Robin Bain. I'm presenting on behalf of STEND in South Africa, as well as my co-authors from Rhodes University in South Africa. Today, I'm going to be discussing the quality of shipped drinking water in a drought-stricken country. I'm specifically looking at the viability of bottled water as a source of alternative potable water by looking at its microbial quality as well as its carbon emission impact. So South Africa is a drought-prone country, and it was declared a drought disaster region in 2019. The average rainfall for our country is 464 millimeters, which is very little compared to the global average of 860. Our erratic rainfall patterns, increasing demand due to a growing population, and poor infrastructure management and maintenance increase the country's susceptibility to drought conditions. The Eastern Cape, Western Cape, and KwaZulu-Natal have been the most affected. I'm sure everybody's seen about Cape Town reaching day zero. The insufficient water supply in the Eastern Cape has caused a disruption and breakdown of services across the province, including the Makana municipality. The drought has had extreme social, environmental, and economic impacts, all of which detriment the overall health of the population and area. It is necessary for us to identify alternative sources of potable water to compensate for the disruptions in municipal supply. Many communities have had to turn to alternative water sources, such as rainwater collection tanks, the use of streams and springs, boreholes, and bottled water. It's important for all possibilities to be thoroughly explored to ensure that informed decisions can be made in disaster situations and relief activities. In our paper, we study the use of bottled water as a viable alternative, specifically for relief activities. So for drought as a whole, drought is typically classified according to its impacts. So meteorological drought is classified by the initial impacts of a prolonged shortage of rainfall for an area. Agricultural drought is classified by the insufficient soil moisture and water supply to sustain crops and agriculture. Hydrological droughts occur when the area experiences insufficient surface and subsurface supplies. And socioeconomic droughts are defined as the demand for water being greater than the water resource systems, and therefore resulting in a decreased economic development. So drought propagation therefore refers to the increased severity and duration of a drought across temporal and spatial scales. Starting as a meteorological drought, drought conditions and impacts progress to affect agricultural and hydrological spheres, ultimately resulting in social and economic consequences and becoming a socioeconomic drought. The increased severity of drought is caused by both natural and anthropogenic factors. The main driver, however, is climate change. Drought is a slow onset disaster and is therefore heavily influenced by climate characteristics. In South Africa, the effects of the El Niño Southern Oscillation have resulted in an even longer prolonged period of reduced rainfall. This has been severely exacerbated by climate change. Climate change affects temperature and rainfall patterns, which are core elements of drought. It has been attributed to the increase in the number of multi-year droughts across South Africa. Due to its amplification of patterns, slow onset disasters, like droughts, cannot be viewed independently of climate change as a whole. Due to the direct link between exacerbated drought conditions and climate change, it's necessary to ensure that all relief activities do not compound the driving factors of this disaster itself. It's vital to ensure that carbon emissions of the relief activities are kept to a minimum to reduce the aggravation of the drought and cause compounding consequences. So water is essential to preserve economic, social, and environmental activities. The three essential roles of water for humans are drinking water, sanitation, and hygiene, which are also known as the WASH principles. According to the World Health Organization, each person requires a minimum of 15 liters of water per day. This water should meet the required health standards for potable water. The South African Department of Water and Sanitation defines their responsibilities in the Government Gazette. They outline the minimum requirement of 1,500 litres potable water per household per week. This water should be available 52 weeks per year, be within 100 metres of the household, and comply with the South African National Standard 241 for domestic water. The most recent statistics show that in the Eastern Cape, 75.1% of households have access to piped water. For the Makana municipality, the Integrated Development Plan for 2021 to 2022 shows that over the 19,300 total municipal households, 53.74% have access to piped water inside the dwelling, 27.65% have access to piped water within the yard, and 8.54% have no formal access to piped water. The IDP for 2021 to 2022 also acknowledges that although it is of acceptable quality, the water does not fully comply with the SANS 241 standards. These stats also don't include the supply disruptions to households which are caused by the drought-impacted water systems. So for the methodology, to test the viability of bottled water as an alternative source, the quality was tested and compared to the SANS standards. The bottled water was sampled from Cradock, Colesberg, Bloemfontein, and Carletonville over a period of 3 months, from June to August of 2022. 750 ml, 1.5 litre, and 5 litre water bottles were tested. The sampling took place over 3 separate sampling occasions. To determine the water quality, the sampled water was tested according to its pH value, turbidity, concentration of fecal thermotolerant coliforms, and for the second and third sampling occasions, iron and nitrates. The SANS 241 standards state that for potable water, the pH values should be within 5 and 9.7, the turbidity should be below 1 NTU, the fecal thermotolerant coliforms should be undetected in a 100 ml sample, iron should be below 2,000 micrograms per litre, and nitrate should be below 0.9 milligrams per litre. Testing strips were used for the pH testing iron and nitrates. A portable turbidity meter was used to test the turbidity, and membrane filtration techniques and MFC agar was used to determine the concentration of fecal coliforms per 100 meters or per 100 millimeter sample. So for the methodology for the carbon emissions, there were 2 different calculations which we used. The first one was used to calculate the carbon emissions of the first 2 sampling occasions. And in this, it made use of a fuel consumption-based carbon emissions calculation. Both sampling occasions were calculated for a 2014 sedan that runs on petrol. The calculation was TCE equals to D times C average times Y. In this calculation, TCE refers to the total carbon emissions. The D refers to the distance. C average refers to the average consumption of petrol that was used per kilometer. And Y refers to the total carbon dioxide produced per liter of petrol, which is also referred to as the conversion factor. To calculate the potential carbon emission for future relief activities, an activity-based approach was used to make use of those transport activities. These calculations were done for the most common relief vehicles, namely a sedan, a bakkie or pickup truck, a van, a small truck, and a truck. The carbon emissions were calculated for different distances, namely for trips to Cradock, Colesberg, Bloemfontein, and Carletonville, also where the sampling took place. The equation of TCE equals to W times D times DEF was used, where the TCE is the total carbon emissions, the W is the weight of the total goods being transported, D is the distance traveled, and DEF is the distance emissions factor, which dictates the average carbon emissions produced per mode of transport for 1 ton over 1 kilometer. These carbon emissions were calculated for a return journey, where the initial trip carried no additional weight, and the return trip carried the maximum load of 5 liter water bottles. The load was calculated using the average dimensions for a 5-liter water bottle and the load carrying ability, both space and weight, for each mode of transport. The total carbon emissions were then divided to determine the total carbon emissions per 5-liter water bottle and then per individual liter of alternative water. These were compared to determine the most carbon efficient form of transport. So for the results, these can be seen in the table. These tests were performed to generate results that could then be compared to the SANS standards. The pH results ranged from 6.11 to 6.78 over the three sampling occasions. This fell within the required range of 5 to 9.7 as dictated by the standards. The turbidity was measured as 0.00 for all of the occasions, which was below 1 NTU, and therefore confirms it is conducive with healthy human consumption. The iron measured in the second and third sampling occasions was 0, which was below the 2,000 micrograms per liter required. Nitrates in the second and third sampling occasions ranged from 0 to 0.1, which also fell below the 0.9 milligrams per liter requirement. Finally, the fecal coliform count for all samples was undetected in 100 ml samples, which confirms a hygienic water source. All of these levels did comply with the SANS 241 standards and can therefore be considered as a viable alternative source of water based on the microbial water quality. So for the results of the carbon emissions sampling, the results made use of for the sampling sessions made use of the fuel consumption-based calculations. These results showed that the first and second sampling opportunities had a carbon footprint of 227.81 kilograms and 298.3 kilograms, respectively. These calculations are useful in providing a basic idea for the values of the relief activities. Cool. So the table shows the results for the carbon emission calculations for future relief activities. In these calculations, the sedan was able to transport 57 5-liter bottles of water, the bakkie or pickup truck, 182 bottles, the van, 1,045 bottles, the small truck, 1,740 bottles, and the truck 5,040 bottles. It's also important to note that the sedan and pickup truck were petrol-powered vehicles, while the van, small truck, and truck all used diesel as fuel. The fuel conversion factor for petrol is 2,392 grams of carbon dioxide per liter of fuel used and 2,640 grams of carbon dioxide per liter of diesel. For a simple comparison of the different modes of transport, we can look at the total carbon emissions per liter for the shortest trip, which was to Cradock. So the TCE for each liter of water transported was 175 grams for the sedan, 85 grams for the bakkie or pickup truck, 47 grams for the van, 58 grams for the small truck, and 28 grams for the truck. This table shows us that in the case of transporting the maximum water to the drought-stricken area, the truck is the most carbon-efficient mode of transport. This is followed by the van, and then the small truck, and then bakkie, and finally the sedan. The small truck was the only example where, despite transporting 695 more bottles than the van per trip, it still had a higher carbon emissions per liter of water. Okay. So the viability of using bottled water as an alternative source of potable water in disaster response activities tested both the microbial quality of the water and the impact of the activities through their carbon emission totals. The bottled water was sampled from Cradock, Colesberg, Bloemfontein, and Carletonville throughout the sampling process and showed compliance with the SANS 241 standards for domestic water. The pH, turbidity, iron, nitrate, and the fecal thermotolerant coliform counts were well within the requirements of the standard and can therefore be considered viable potable water sources for relief activities. The second scenario ensured that the relief activities minimize their carbon emissions contribution and therefore their contribution to climate change, which would have exacerbated drought and its impact. This was done by measuring the total carbon emissions emitted during these transport activities. The results showed that there's a direct correlation between the distance, direct correlation with an increase in distance causing an increase in total carbon emissions. It's therefore important for relief workers to identify the closest source of bottled water to reduce the carbon emissions for the activities. The results also showed a correlation with the amount of bottled water transported being associated with the decrease in the total carbon emissions per 5-liter bottle. The exception of this rule was the small truck, which, despite having greater carrying capacity than the van, had an increased total carbon emissions per 5-liter bottle. These results indicate that for bulk water transport, the best mode of transport is the truck. However, due to the heavier vehicles showing a direct correlation of having a greater total carbon emissions count per trip, again with the exception of the small truck, it's beneficial to ensure that the exact amount of water required is calculated prior to the activities. And then the smallest mode of transport capable of transporting that required amount is then selected. So these are the references that I've used for the study. If anybody has any questions, I am more than happy to chat with you.
I don't see any questions at the moment, Robin. Thank you very much. And now we'll go to our next presenter. So next is going to be Craig Hansen, Dr. Craig Hansen. So let me just bring you up. Welcome to the conference, and very much looking forward to your presentation.
Good morning, everybody from New Zealand. I know it's afternoon there in Atlanta, so thanks very much for having me. Kyle, thanks for your efforts making this all happen. Really do appreciate everything you're doing for TIEMS, and thank you also to Harold for the opportunity in coordinating such a big event. So welcome, everybody. My name is Craig Hansen, and I'm the founder and president of the University of Applied Research and Development. We're internationally accredited, and I'm based in New Zealand, which is where I'll be presenting to you today from. So I'm going to share with you some research results from Manlin Corsi, who's based in the United Arab Emirates. He's an international firefighter. Also from Tony Fogarty, who is a senior fire consultant in the UK. Manlin Corsi completed his bachelor degree in emergency response and risk management with us. And then also Tony completed his master's degree and has gone on to do his doctoral studies in the States and in Europe. So if you want to find the full research from Manlin Corsi or from Tony, you can find it on academia.edu, either on my profile or on their profile, where we have co-authored and co-published their full research. And you can find a picture of what that looks like on the screen right now. So from Manlin Corsi's bachelor degree research, you're really focused as a pragmatically focused paradigm of identifying challenges and identifying solutions. So from Manlin Corsi's environment in the Middle East, there's high growth, commercialization, lots of industrial areas being built, and residential zones as well. And many of these are clustered together, which and then the terminals that produce oil and also the production there are called critical infrastructure. And the same terminology is used internationally. So when I refer to critical infrastructure, we're talking about that infrastructure that's part of the supply chain to keep a nation moving or a region moving, such as electricity and oil production. Often the terminals that are there are producing oil or refining, or they don't have a fire water backup line or any ring main tapping from the sea. What this means is that if there's a fire response needed, there's not enough water to adequately respond to that fire situation. Also, there's a lack of training or practices and drills or exercises built in to not just individual fire response teams and individual terminals or outside the terminals, but globally around those regions. And so there's no interaction between the different departments and teams as well. So the resources and the lack of collaboration or memorandums of understanding means that there's a disjointed response to an emergency. There's also no central emergency response or emergency control center or incident command center in the critical infrastructure areas, particularly in the highly developed areas that have terminals, commercial and residential areas close by. Also, for fire engines and emergency responders, there's no particular vehicle lanes that are set up for egress for the first responders. Also, for teams that are from one fire department, they often have restricted access entering into specific terminals or critical infrastructure, they require someone from that particular installation to physically manually swipe them through when they need to get through to respond to a fire incident, a terrorist incident, or something that's been created as a response to workers making a wrong decision. And because the terminals are very clustered together, physically close, and the lack of coordination, communication, or working together, that means that the function and response of the emergency responders is really hampered. As we've already heard today with one of the other presenters, mental health is a big issue for emergency responders. As COVID-19 has shown us, when people are responding 24 hours a day, 7 days a week for extended periods of time, mental health is built on top of physical fatigue. And that creates a real problem for situational awareness and the ability of organizations to respond to emergencies. And there's a lack of mental health awareness and support in the Middle East area. So just to look at some of the generated solutions from Madeline Cossey's research, from working with his own team, working with other people in that region, they really believe, and he believes, and is captured in his research response, even at bachelor level, that there needs to be a common fire water ring main installed so that firefighters can have adequate supply of ongoing water to respond to fire situations, whether that's a processing problem, whether that's an explosion, whether that's a terrorist attack, that just needs to be water. The installation of fire pumps needs to go with that ring water main, so that where there are leaks, where there might be a terrorist attack, where there is a breakage, the pumps can then provide the pressure that's needed to respond to the size of the fires that are in these particular critical infrastructure areas. Also, there needs to be an incident command system or an incident management system that has common terminology and a recognized structure, because the fire responders are drawn from all around the world. Their expertise is brought into the Middle East, yet there is no one particular training institution that mandates a particular command structure, and then also the terminology and the way of responding to each other in an emergency situation. So Madeline Cossey has identified these particular solutions pragmatically that need to be implemented in the Middle East, particularly in these high development areas. Continuing on from that, there needs to be ongoing training and also exercises at a tabletop level and then a practical level as well, that includes collaboration between the hospitals, between the experts on site in the terminals, because they know their area well and they know it better than the first responders to know what sort of chemicals they're going to be responding to, so they can have the right retardants and foams brought in to respond, because water isn't the answer to every explosion. Also, the police and knowing how to respond to the local news media so that people can be aware of what the problem is, how it's being responded to, and how long that would take. The industrial zones themselves need to have a main central command center. From that will drive all the first responders and the emergency responders and the fire stations and the coordination and the communication. And those industrial zones need to have that standard egress and fire lanes for those engines to hit the ground running, to get there on site really fast, and to communicate with each other, and then to leave the site so that the recovery phase can then move in and be delivered. So these are Madeline Cossey's solutions that he's suggesting to the problems he's identified at this regional level and even at bachelor level through his research. So I do want to commend Madeline Cossey for what he's done to really become a thought leader in this particular area. So just moving on to Tony Fogarty's research, his area of real concern was the pollution impact in local areas when there's fire water runoff. So when a fire and first responders jump into a situation and they launch water or chemicals or retardants to dampen a fire, that will often flow overland into the local drains, local river systems, and there's no real management of that fire water runoff. And that contamination often goes into the local environment. And there's a lack of sprinkler systems that are designed and water distribution systems designed. Right from the design phase, there's a lack of that to counter fire water runoff. There's a lack of overall awareness in the industry and a lack of leadership in this particular area. So Tony has become a real leader in this area through his own research, and he's identified by talking to other consultants that there seems to be this absence of leadership, an absence of equipment maintenance, an absence of sprinkler systems, apart from the largest of warehouses. And so in the United Kingdom, this is a real problem that Tony has identified, a lack of training for fire safety professionals and how you respond to and manage fire water runoff. Often there is a high degree of training to respond, but then dealing with the water that overflows into local areas, there's a lack of training and awareness about that. So fire and risk assessments by consultants and senior fire leaders is not being done in a training level and at a design level. So Tony identified a number of challenges, but also identified a number of solutions by talking to other consultants and senior fire leaders. Number one, that owners and occupiers should be trained, and there should be requirements around this. So whether they're in a large, medium size, or a small industrial site, they really need to be trained and have requirements around how fire water is dealt with. Because there's a lack of equipment maintenance, there should be a maintenance system in place. There should be an asset lists created. There should be operations manuals for small, medium, and large industrial sites that are available for inspection by local fire authorities or fire consultants. Sprinklers need to be mandatory, and the types of sprinklers are adequate for the types of chemicals that are being produced or used in those industrial sites. The ongoing professional development needs to be mandatory, needs to be in the regulations and part of the ongoing management and also the assessments that happen on a regular basis. Fire water runoff should be considered the design stage of industrial building design. Ongoing assessments need to reflect that, and an improvement of collaboration between local authorities and the owners and occupiers of the actual industrial sites. So as you can see from Tony's research and also Madeline Kossi's research, we have a focus through UARD of having not just identifying problems, but identifying solutions by working with subject matter experts in those particular areas and allowing people such as Madeline Kossi and Tony, who have a real degree of interest in this area, to become thought leaders and solution providers and generators, and sharing that information openly and creating open source responses to that. A third area of research that we're involved in at the moment, which is a personal passion area for me, personal passion area, try to say that fast 5 times, is about drones and the use of drones in emergency management and response and recovery. And I do want to acknowledge the work of David Danielson at NIST and John Hopkins, and also Richard Fields, who's a senior firefighter and deputy chief in the Los Angeles Fire Department. He was one of the very first drone users in the United States in fire response, and a real innovator and pioneer in that area. Some of the challenges that have been identified is that ongoing drones are being used for criminal activity, drug trafficking, terrorism, and human trafficking as well. And there's a proliferation of drone makes and models, which means that it's very hard for law enforcement agencies and first responders to really find where did this drone come from, who was using it and what for. And the complexity of data and its storage due to the proliferation of makes and models. Related to this is that it's very, very difficult and challenging to get flight plans approved because there's a lack of live data available for drone deployment. And getting approval from the FAA in America and other flight authorities in different regions, particularly when the GPS or Wi-Fi services are knocked out. If there's a terrorist attack or an earthquake, a natural disaster, the change in the terrain means that first responders have a real difficulty responding accurately, saving time and having situational awareness and that information flow. So really that accessibility of drones during the recovery phase is dependent upon infrastructure that needs to be thought of in the planning phase of emergency response. So some solutions that David and Richard and others and our own research that we're investigating at the moment is what I'm going to present to you now. So some solutions that we've identified is that, for example, with NIST, they've identified and they're developing an open database of all the different drone clones. So they're developing digital clones of all of these different drones. This means that emergency responders and law enforcement agencies can very quickly have tear down instructions So if they get this drone, they can take a photo of it, upload it to the database, and a match can be found very quickly of this type of drone. That means they can take them apart, find the initial flight plans in there, find where it came from, who was the manufacturer, who bought it, where was it used, what are the photos and the videos there in the device. They can do that at speed because of this open database, which means that responses can increase their situational awareness and also the speed of response. Also, there's the UAS Triple Challenge, which is crowdsourcing innovation. If you think of Google's moonshots or NASA's Let's Go to Mars crowdsourcing innovations, they're offering cash prizes for innovative ways to use drones to respond to emergencies and fight terrorism. Also, there's interesting work being done by Ideal Drone in Turin. They're using UAV swarms, so drone swarms, very small drones that are released in their tens and hundreds to identify and find people in large industrial spaces where people may have been, where people may be stopped because of a fire, because of an explosion. They're all clustered in one place. What this does is it increases the information flow. So the drones will identify where there are RFID devices or ID cards or mobile phones clustered together, because that's where the people will be. So they can send in the first responders and the rescuers to one place. Instead of having to search, they can actually respond. Another example of drone use is Philippines Flying Labs. They're able to send out drones autonomously that will fly out and deliver test kits for vaccination to increase community capacity building, and that they can also fly out autonomously and pick up those completed test kits so that the right vaccination can be delivered to very far off and remote areas. So drones are being deployed in a range of different ways, and the community of emergency responders is working together to provide information to provide a fast response. Also, Belgium's SAFIR Med project is providing the delivery of flight path submissions at speed. This enables drones to be released to respond to emergencies and also low altitude surveillance. What does this do? It enables a risk assessment to be completed very, very fast. It allows 3D scanning of the environment. It allows LiDAR to provide subsurface scanning for emergency responders so they can see not only what is above the ground, but what is below the ground in really critical situations. This improves the information flow and the situational awareness for emergency responders. Also, drones allow us the opportunity, such as Africa's zipline, to drop supplies and then repeat that cycle of food and medicine and supply delivery on an autonomous schedule so that it isn't dependent on humans. This means that the fatigue and the mental health of responders can be cared for while also increasing the supply of critical medicine and food in difficult situations. And here you can see China's EHang 216, which is a drone which has its own water supply, high pressure pumps, and it can reach very high residential and commercial levels and heights without the need to be tethered to fire hoses, which slows its ability to respond. They also have foam missiles, which can deliver a foam response at very high altitudes. This model that you're looking at on the picture here has 6 projectiles on the top of the drone, which can fire a missile filled with foam that can retard a fire very, very quickly to allow emergency responders to save lives. So I do want to thank you very, very much for your time. And I hope that the research that we're involved in right now and the research results of Tony and of Madeline Kossi will give you some idea of what we're doing with UARD. And we hope to contribute in a very pragmatic way to solutions for emergency responders and agencies as well around the world. So thank you very much, Kyle. I'll hand back to you.
All right. Thanks a lot, Greg. It was very, very interesting. And I think we're just starting to see the advent of drones and technology and things like that, and sort of the rapidly changing environment that we're living in these days. So it's a very sort of interesting space to be looking at. So best of luck with your research, and hope that develops very well for you. And in terms of the next presentation, it actually takes us right into the next presentation. And so now we'll just welcome Jacob. Jacob, welcome. I know we're probably around in the same time zone, so appreciate you staying up late with us to give your presentation today. So I'll just turn it right over to you, Thanks.
Thank you very much, and I hope you can hear me well and see my presentation as well. Thank you. Indeed, it is more than 22:30, but also we are actually in the center of the mountains during the experiment with using drones for the search and rescue in the mountain areas. So that's quite interesting, and I hope the connection will be sufficient. But I will not speak about the specific implementation of drones technologies, not today, even if I very much appreciate the previous presentation. I will speak more about the strategic context. But in this sense, let me just emphasize that we indeed see the growing number of drone applications for the crisis management, for the rescue operations. And we basically see drones as being used as a kind of a moving camera source of information, of observing the situation on the ground, and as a source of aerial photography and mapping, which can also be quite useful in crisis situations. We've been doing this for a number of years ourselves, and I think this is the area where we have a huge advantage still to be appreciated by the users. And of course, we have the search and rescue activities where drones can provide a very specific information support. And so these are only three of the areas which are worth emphasizing, but there are many more. But what is very important, if you want to use drones for crisis management, for rescue operations, you really need to have a way of organizing a safe and efficient way of conducting their flights. And that's exactly what I'm referring to, the search and help system. This is something which is being implemented in Poland at this moment. It's a part of the national infrastructure for UAV or UAS, if you prefer, unmanned aerial systems environment to ensure safe flights. And the specific applications for crisis management are a significant and important element of this environment. Basically, we believe that drones can provide a very important improvement in efficiency of crisis management operations. However, this represents also a challenge of how to ensure coordination in the sense of safety, enabling safe conduct of operations, and also efficiency of those operations. We ourselves are the entity which is very much devoted to optimizing use of innovative technologies in the crisis management domain. Our motto is the right information for the right people, the right time, and the drones, together with satellite applications, are two main means of providing this information. So we are working with the existing solutions to ensure that they are fully utilized among the user community, but we are also developing new methods. We are supporting those who have specific technical competencies to build the solutions which are the most effectively addressing the needs of the end users. And finally, we are just supporting the end users in increasing awareness and competencies in those fields which address using innovative technologies. But it's enough about us. We have a pleasure to work closely with the Polish Air Navigation Systems Agency, which is the national authority for air operations in Poland. And we are acting as the functional author of innovative systems which are being implemented just now. But to put it in a wider context, just 2 years ago, in April 2020, we had a huge, in case of Poland, the largest fire of green areas. It was not exactly forest, it was a national park, but more like the grassland area. More than 4,000 hectares. For the Central Europe, it's a lot. Of course, it wouldn't be a lot for United States, Canada, or Australia. But in our situation where we are used to catch the fires very rapidly and locate them and minimize them, this was a huge one. But the problem was we had some drones which could be used as a very useful way of providing the strategic overview of the situation. But the problem, at the same time, we had the observation helicopters with the crew on board, and we had the firefighting planes and also firefighting helicopters. And because of the basic structure of and the basic standard procedures for conducting air operations, the drones were not allowed to fly, to launch during the time when the human-operated aircraft were in the air. So this was the example of the challenge. We have a technical capability, but we cannot really benefit from it because of this safety concern. And that's why we organized the next year the large air component of another firefighting exercise. And I had the pleasure to be a coordinator of the air operations during this exercise. And we managed to demonstrate that we can effectively have drones and human-operated aircraft at the same time in the air conducting their operations. They've been able to conduct it safely. And I think with almost 100% efficiency on both sides, on the crew operated aircraft and on the unmanned aerial vehicles. And I think this was a very important demonstration because this gave a real green light for implementing a specific system. We call it Surge and Help, which is aimed at providing the ability to coordinate these kind of flights in different type of emergencies, both in large scale and medium scale emergencies. We expect that people will be able to declare the conditions, the boundary conditions of the flights, and then it will be possible to ensure safety of operations in the environment when we have both types of aircrafts in the air at the same time. So basically, what we are doing, we are working together with the air traffic called Dynamic Safety and Security, and Search of Help with a specific module name. I hope you can still hear me. I'm getting the message that the internet connection here in the mountains is not stable, but I hope it's okay. And the system is being under development now. We plan to have it deployed by the end of the next year. And it provides two levels of services. It is expected that all drone operators, the drone operators from the emergency community, will have access to a specific application, and they will be able to give two types of information and get two types of information. The threat tactical, so that you are declaring your intention to conduct a specific flight in a specific area at a specific time, and you can coordinate these declarations. And then a tactical coordination. Tactical means during the flight, you are given information about possible conflicts, and in particular, the conflicts between the drones and the human-operated aircraft. And we assume that this will be a solution which will be quite effectively working for the small and medium-sized crises. But at the same time, for the medium and large scale crises, we are expecting to have the air traffic personnel involved conducting the actual coordination. And what is very important, we are planning, and this is already implemented here in Poland, where we have a system which enables you to declare and close a specific part of the airspace for emergency operations. As a result, you get the firefighting officer, or it can also be a police officer with appropriate training, to take over control over whatever happens in the air over the operation. This person, as I mentioned before, can be supported by the air traffic control personnel, but in smaller cases, even this person himself using the application can be able to coordinate the activities and ensure the safety of these activities. And in a second priority, also an efficiency of these operations. So basically, what we are doing is exactly what I mentioned, that we are able to establish an airspace segregation, a close a specific part of the airspace. We have this pre-tactical and tactical management. And the system itself enables you to share information. You know who is planning to do what and where, and you know as a pilot, as well as the coordinator, what is going on. You can intervene, you can negotiate, and basically you are operating in the information-rich environment. You know what is going on. You know what might be a challenge to you. And consequently, you are also able, and you are also able to ensure that the safety of your if it is not participate in the activities and this time in this specific area. At this moment, we are conducting this as the activity which will be conducted in the declaration mode. So pilots are informing when they're going to fly, but we are expecting also to have a second wave of the development when we will be able to get the real-time monitoring of the position of aircraft, both the operation aircraft and also the actual air situation in the real time. And what is also important, we are going to enhance the system so the people are able to exchange some basic information about the situation on the ground. This will be also useful for having the information about the situation seen from the air shared among the practitioners. Of course, I'm talking about the closed system. We are not sharing this information with everyone, only with the pilots who are authorized to participate in the emergency operation. And what is also very important, to all these. It's also about the procedures, about the operation practices, which should be shared and established as a kind of a common standard among the community. So when you are participating, you know what will be the behavior of your colleagues and how you should behave to be part of this concert of coordinated air operations. And I think we are on the good track to achieve that. Concluding, we expect that we will be able to increase efficiency of emergency operations, and the ensuring safety and coordination of those is a way forward. The IT system is very much needed for this. The same IT system can also be used to have to be able to share at least selected information about the ground situation among the users, the practitioners. Finally, in the long run, we are thinking about the real-time air traffic situation monitoring, and this will be providing an additional layer of safety for those coordinating and supervising the conduct of air operations. And in this context, it's also worth to mention that we had a pleasure, or we will have a pleasure to coordinate the network of the Colaris network. This will be a network, the European network of users of drones in crisis management and emergency operations. We are doing this as a part of the knowledge network of the European Union Civil Protection Mechanism. And this will be exactly the platform for discuss this kind of solutions, of applications, of experiences, to share the good practices, to share the information about national solutions, and to work towards having more effective use of drones among different people, just to getting most from the experience of others, and trying not to reinvent the wheel, in terms of the ideas, but also in terms of the ways that this can be implemented on the national level, in terms of the legal solutions, in terms of the operational practices, and just the pilots' competencies and all personal competencies. So in this context, I'm also very much looking forward for opportunity to discuss experiences from my previous speaker, from the speaker who gave a presentation before me. I think this is the Colaris network could be a very useful platform to having these experiences really presented among those who are the most interested in absorbing this knowledge and putting this into practice. With that, I would like to thank you. I hope this was a short and concise information set, and I also hope that this for some of you, this might generate a few ideas what could be done, and we would be more than happy to share more information about what we are doing, how we are doing, and what part of this could be transferable. And from that, I would be very happy to be contacted by you, or I can also respond to any immediate questions you might have. Thank you very much.
Okay, thank you very much, Jacob. Really appreciate it. Very interesting presentation. And again, like I mentioned with Dr. Hansen, that I think we're just starting to see this emerging technology, even though it's been around for a while. In terms of sort of growing and development, I think we're going to see a large push of that coming pretty soon. So thank you very much for that. And how do we find out or follow up with you for more information? It's on the Colaris network, is that right?
That's correct. We have not yet established the network, the web page for the network. It is the work in the progress. Formally, we will be launching the whole thing on the 1st of January next year. But if you just remember the name Colaris Network and Google it in 2 months, you will find it for sure. Or just please contact me directly, and I will be more than happy to put you in touch with us.
Perfect. All right. Thank you very much. Thank you for the presentation. And so that brings us to the actual closure portion of the results or the conference for today. And so what I would like to do just very quickly is to just cover a few administrative remarks as we close out the day. So a lot of great discussions today. We started out a little bit rough in terms of getting our speakers on board, but things happened, especially for our Ukrainian colleagues. But lots of great discussions, information presented today in terms of the way that we look at crisis, emergency management, different tools, technologies, capabilities. And remember that look for the day 2 Zoom registration piece. So now after today's conference, we're going to register everybody who has registered for the conference this week. We're going to put them into the Zoom system and register them for tomorrow. So they will get an automatic invitation for the Zoom webinar for tomorrow. And that will specifically say day 2. So make sure you follow that link, and then you can join us tomorrow for the rest of the presentations. So use that link to join in tomorrow. And thank you once again for attending. You'll be getting that email shortly. And make sure you follow that and attend tomorrow for some very interesting presentations tomorrow. So with that, I would just like to say thank you very much for your time and for being here today. And really looking forward to seeing everybody tomorrow there. All right. Thanks a lot.